this video, I would like to start to create a quick sketch for the stairs based on the construction assemblies. This quick video is only helping those students who have the knowledge of the building assemblies and all the components that we are going to discuss in this PowerPoint presentation, and then right after that you're going to watch a simulation in AutoCAD. The objective for this, as I mentioned already, is in this short tutorial you will learn to calculate the number of stairs based on the Ontario Building Code and draw a preliminary section in AutoCAD. ABC is Alberta Building Code, Ontario Building Code, both standing in the same numbers for the stairs standards. The maximum height is 180 millimeters, which we are going to use that. So if you are in Ontario, Alberta, or even in British Columbia, you can use this. I would like to explain three major steps into building this exercise. So the process of the calculating the floor assembly thickness, how we are going to consider that. Then we are going to dive into the height into the equal pieces between the two floors. So we are going to divide them all in the same numbers, which should be less than 180 as building code says. And then we are going to complete a preliminary sketch for the stairs. A stair itself has a really dedicated, a specific assignment. I would introduce that later on, but for this purpose of creating a mini floor plan and being able to complete the floor plan for the projects that we've been working on throughout the whole semester, this is going to be a very good exercise and a good start. Okay, let's dive into it. First, you need to understand the assembly. So the assembly for this building is including, as you can see it here, including the metal deck and the open web steel joists. So the open web steel joist booth is 64 millimeter, and the corrugated metal deck, including the concrete topping on that, will be 100. So altogether, that's going to be 164. All these numbers are coming from the manufacturers, and we discussed that in our methods and materials class, which is basically taught in our college. For the underside of the deck for the roof, we use this number as 7,828. We'll get to that when we are basically in the methods and materials class, and the parapet height is 600. I'm not going to take you to more than the second floor. I want to keep it simple. We are going to go over a very short tutorial, and you are going to learn how to divide between the main floor, first floor, and the second floor to the steps and see how many steps we need first, and then how you are going to draw it in AutoCAD. Okay, so this is basically what we are working on. Stay with me, and I'm going to take you to AutoCAD. I'm going to use AutoCAD 2023, and very simple process to draw a very preliminary sketch. It's not going to be complete. As I mentioned, the assignment for the staircase is going to be different in the coming tutorials, but for now you need to know how many steps you need and how you are going to draw it quickly. Okay, let's dive into it. Okay, so let's take a look into this floor plan. The story starts from this building that we want to build a quick stairs in this area. In the end, we are going to mirror that to this side of the building as well. So we are going to start from the west corner of the building, and we'll take a look at it to see how it goes. And eventually what I'm trying to explain today is the cut through the stairs, and then you are going to see this section 3 on different drawings, which in this case it's a A7.1. Okay, so what is the story of all these blocks? We all know this building has made by concrete block, and we want to add a staircase with the use of concrete block in here. So I created a block. They are all in non-print layers. So as you can see, they are on depth points. These blocks are 390 by 190 and 10 millimeters. It's the mortar between each block. So if you take a quick dimension from that end to this end, I'm going to put the measurements on. As you can see, this is 390 by 190. So that is the standard concrete block here in Canada. We start from one corner and then we create 1, 2, 3, 4, 5, 6, 7, and then the eighth one is going to return coming back as it is going to be used for this staircase. I will explain how we are going to do the stair. However, we need to have a base based on the concrete block sizes. What I have already made in here, this is a door block. This door block is a dynamic block and it is possible to pull it in and out and make it different sizes as we want. However, I made it already to the size of the exit door. I will move this back to the place that I have already made for, which is going to be in this wall, right? So this is one door gets out, and then I will copy it from this corner to put it in here. So that's going to be basically the exit to outside of the building. I'm going to move this away from the graphic, so I don't want to have interference with the graphic and the architectural elements, in this case door. Hence, that's a good practice to move it away. And as you can see, this door is completely 2.5 block based on what the exit door size should be, and that's not less than 900 millimeters. This is a 3 foot by 7 foot. Most of the products in Canada comes from US, and the imperial metric, as a learner, you should be able to translate from and then jumping from one to the other. Okay, so here is the situation that we have all the blocks laid out around where we want to put it. The relation between the grid line here, grid line number 2, with the block is similar to the grid line B as we've been discussing it in our sessions, 10 millimeters away. So the face of the concrete block to the grid line is 200, and this is how the pillars are sitting in the corner of the building. We'll get to the building envelope later on. We discussed that in class, but that's not the topic. We are discussing it today in this tutorial. Okay, so here we are. We want to cut through these and then creating a staircase right in here. And then how we are going to do that. At the bottom of this page, as you can see, this is a sketch. I laid it out already. We start from the main floor slab, or better yet, first floor slab, and then bumping it up to 3,764. So this case provides the floor to floor. The wall height was 3,600, 164 added to 3,600, which becomes to 3,764 for the floor to floor height. Now, what I'm going to do, go to, on this page, this is the letter size. In case if I want to print it, it's going to be complete in the letter size. I'm going to create a quick line from here to there. And as you can see, if I get a list of this drawing of this line, this is the table, comes down in here, and it gives me basically the length as provided in there. So that is completely clear that the height of this line, the length of this line is 3764. Okay, so what we are going to do now, as we are using the calculator, 3764 divided by, I use divide in here, divided by 180, because that's the maximum height based on the building code. And then it gives me 20.911111. This number is not a clean number. So we are gonna round it up. So the number of steps I need always has to be round up. In this case, That's going to be 21. So now I have that 21. We're going to divide 3764 divided by 21, and this is going to be the size of a stair rise. So the manufacturers, the shop, is going to build this 21 steps based on that numbers, and then that's their job to do it in a shop with the very accurate tools these days, and they will bring it to the job site. However, drawing this with all those fractions, it's going to create a big problem in my AutoCAD, which I don't want to see it. What I'm going to do first, I'm going to call for PD mode. You'll see that's what it is. And then change that bracket number is right now is at 3. Yours should be 0 because by default, AutoCAD puts it in 0. I would change it to 3 as what it is. And then I would use the command divide, which is divide right there, right? So click on that piece. So I want to divide that piece to 21 pieces, bang. And this is creating all those nodes for me. These guys are nodes, right? So these are nodes. When we change the PD mode, the node size is going to be, the node shape is going to be different from what we basically just observed right here. So if I do the divide to 21, based on this, I'm going to lock this to make sure it's not going to move. Then I'm going to get close to it. Okay. Make sure your object snap, as you can see it here, that node is on, otherwise you can't grab them, okay? And then we need to have a polyline from here, go up 25 millimeters out for 1 inch nosing, 25 millimeters down for the nosing, and then close it. So this little piece right there provides me with the guideline to how to create my first step. I'm using polyline again from here, up, nose, back in there, and then I'm going to go 300. That's how I'm going to create the first step. So the run cannot be less than 280 based on the Ontario Building Code. So copy this and then put it up in here. Right? So this is the first step, and then the second one, and then the third one. I'm going to grow this all the way up to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So I'm going to divide this 11 and 10. If I copy 10 of those and then move them over, and what I'm going to do is just to quickly mirror that and then erase the old object. I will move all these elements from that end to right there, and they have to be at the level. Okay, so let's take a look. Right there, we are sitting exactly on the top of the slab for the second floor, and these two lines are going to be exactly on the same extent. If I would have used this number, it was just impossible to come to exactly where we are at, and that divide command in a geometric way helped me to do these fractions. Okay, what I need to do extra here, I'm going to take this corner and then offset 1200 because I want to have the landing 1200. My staircase is going to be 1200 width, and the landing can't be less than that. In my case, it's 1200. I like that number because it's clean and it is more than minimum 900 based on the code. Right now, I'm going to erase these two guys, and my stair is already drawn, and it can be set in this area later on for providing the access from second floor to the first floor, and then create a path of egress to outside. Assignment number 4, we are going to go over this more detail with all those components for a commercial stairs. So as the exit, you should be able to use that. So I would like to put this one on your bright space for the class, and you people can use it as I explained it. You can stop, rewind, and basically self-educate yourself. For now, this is it. I think I explained everything that you needed, and good luck with the printing. If I do the plot right here, this is the plot setting that I have. Normally I use window. That window starts from one of the corners. As I mentioned before, this is a letter size piece of paper, 216. It's the width, and then the length is 279. That is the letter size. I use the full bleed, 8.5 by 11. This is imperial, always imperial metric in Canada. Everybody has to know that. And this is going to stays on metric millimeter. That is the CTB we are using for our working drawings 3 course. And then when you apply it, it's going to be always available. We are going to do a quick preview, and that's how it should be. So use the center line for the datum for the second floor, use the center line for datum for the first floor, and this is your steps. I'm going to remove that line later on. I don't need it for my section, but this is how you quickly can create the section through your stairs and design the staircase as it's appeared on the other tab I showed you for the framing. Okay. I'm going to cancel the printing, and this is going to be part of the bigger drawing that we are going to discuss for the main floor, second floor. Maybe your floor plan does not look like this, which should not be, and but adding something as an exit stairs, it is a common practice in our industry, right? Eventually, if you want to know how it's going to be look like on the building, this is an exit stairs as you see it on the screen here. And that is a Best Western Hotel somewhere in Alberta, and that's how this little creature is going to take people from inside and then bring them out to this exit door, and they can go to the master point. Basically, the results of this exercise, doing this addition to the framing and creating this stair section, is going to be a creature look like that as a addition to a building. Okay, so that was the closing part. If you want to follow me on LinkedIn and stay connected, for those of you who have not been with me in any courses, by all means, stay awesome and wait for the new tutorials coming out soon. Have a nice day. Bye-bye.